converting straw and agricultural residue into power. So what's the potential for this? I mean, what kind of biomass are we talking about, and what are we really burning off? So we actually see that trash makes up about 10 to 15% of total biomass. I'm talking about sugarcane, but it can differ a little bit when we go to other crops like paddy. Paddy is actually higher, but in sugarcane, it's about 10 to 15% of total biomass. And the untapped potential in Thailand is about 1.8 million hectares. That's unlimited, basically, because we are the 4th largest sugar producer in the world, and we have really a limitless supply of sugarcane trash, because it's just the stock that is used for cane production, and this is year after year. So if we want to convert this sugarcane trash into money, just to get a feel of what we are burning off in every rai of these fields, then this is a very, very rough calculation, but a very, very good estimate of the money that we're burning off. We have about 7 tons of trash per hectare. This is just the trash, because the cane itself could be about 100. And if you look at the heat value, it's about 15 megajoules per kg of this trash, or kilowatt hour per kg, 4.16. And when you convert this to power, we don't have 100% efficiency of conversion. So you assume a very conservative 25% in the process of converting this energy in the trash to usable electrical energy. So even assuming a very conservative 25%, that means 7,280 kilowatt hours or units of energy. And if you assume about 0.04 euro per kilowatt hour, that's about 290 euro per hectare, or to understand it in local Thai baht and rai terms, every rai of trash that we're burning 1,800 baht. And this is something that's then happening probably across millions of rai every year in Thailand. So this is really the amount of energy that we are burning off. And if we were to stop this, we could use this productively, and then at the same time have clean air. So this is actually a picture of the sugarcane plant, where you can see here bagasse, or what is left after sugarcane, after sugar production, that is here. And these power plants actually use bagasse throughout the year, even though cane production or sugar production is there for about 4 or 5 months. But then when you produce power for the whole year, you need then to mix this bagasse with other crop residues, so that you can continue using this bagasse throughout the year. And that's where residue like cane trash or paddy straw really come in. They can help power generation through the year, and then these sugar mills actually become power plants, where they keep supplying energy to the grid. So we've just discussed some parts of this. I'm going into a little bit more detail on the process where CLAAS comes in, or companies like CLAAS, where the equipment or the machinery comes in the process as a solution provider. So the challenge that we have in trying to manage the loose straw, whether it's paddy straw or cane trash, is really the material that is lying across a large area of the field in loose form. So collecting this and then transporting it is something that needs professional equipment, because if you don't have such equipment, and if you were to do it manually, then that's a huge cost. It makes no sense spending a lot of money trying to handle the straw, because then it's not, the whole process is not viable. Another thing is, if it's not compact enough, transportation is very expensive, and by the time we get the straw to the gates of the power plant, then you've already spent a lot of money in freight. Then it's not viable for a power plant, because for a power plant to be economic, they have to compare the cost of bales delivered at the gates with other sources of energy, could be coal or could be other things. And so therefore they will have to make an economic decision as to what to choose. Balers here, what it essentially does is it helps collect this, compress it, and make it bundles that can be then effectively transported to power plants where they are needed in a very cost-effective manner. So what's the process chain? Oh, swathing. Swathing is the first step, but swathing is actually the easier part, but the more essential part, so that the baling becomes effective after that. Swathing is the process where the loose straw that's lying across the field, it's kind of sweep into swaths or lines, so that you create these lines that can then be easily picked up, more efficiently picked up by the baler that comes after the swather. So this is the key process, where you have then the baler going over these swaths or lines that are created here, picking it up, compressing it, and then dropping it off as what we call bales, which are then the compressed form. These bales would then need to be collected. So that's the material handling part, and then of course transported to a power plant. So this is the simple process chain that makes it possible for loose paddy straw or sugarcane trash to ultimately become, let's say, almost like bricks that are then transported to power plants. Now let's look at a video that we have from Thailand, and so that you get a feel of how it looks like in actual practice. So that was some actual videos from the field here in Thailand. So it's just to give you an impression of what the equipment really does physically. And of course, you're all welcome to see these machines working in the sugarcane fields right now as we speak, because the season has started and the balers are actually in action. So of course, there would be some basic questions as to what's the size of the bale, what's the weight, and what's the tractor horsepower. We're not going into too much of technical details. We are of course available for more detailed discussions, but to give you a feel, these bales are about 350 to 500 kg per bale, depending upon the pressure settings. And we could vary the length of this, going up to 300 centimeters, and that's adjustable. The cross section is about 70 centimeters into 120 centimeters. So fairly compact and driven by a tractor, which is about 150 to 200 horsepower, making it very efficient to stack, transport, and later on even store it until it is finally used in a power plant. So I wouldn't go into technicals, but just for the curious colleagues, we have some colleagues from the university as well. So just 4 key steps that actually go on in a baler. You have the first step of a picking up, where the straw that is put into a swath or a line is picked up by the baler or the pickup. The next step is where it is fed into the bale chamber, where it is finally then compressed. And there's an interesting part that comes at the end in these large square balers, which is the knotter. So you have then a knot tied around so that these bales are held secure. And this makes it possible then to stack, store, and use this even later when it's really needed. So this is the 4 main steps of how a square baler works. So now I did show you an image or a video of the quadrant, which is a CLAAS square baler working here in Thailand, but it's not just one, and I'll in a minute share a little more details of that. But what's more important is to really understand some of the engineering challenges that go into the process, because the process of sugarcane thrash baling is quite aggressive because of the field conditions. We've been in Thailand since 2015, but the quadrant balers itself have been in use since 1988. So that's quite a history of the machines. And if you were there in the field at the time of baling, even the video that you saw is quite clear that the level of soil content in the crop is quite high. And that also comes partly because of the way in which they are raked or swathed. The video that I shared with you is that of a mechanical rake where some amount of dust is kicked in or pushed into the bales in the process of making a swath. We of course have more efficient solutions using the CLAAS liners where the dust is not then put into the swath. Even then, you cannot completely avoid the level of dust in the process of baling. So you can see here a picture from Thailand where you can see a very high level of soil content in the process of baling. And the sugarcane thrash, it says stalks itself, there could be some left on the field. They are quite hard, could be mixed with stones, and the thrash or the leaves itself are abrasive. So all this combined contribute to a fair amount of load on the baler. And what we've learned over the years from Thailand has helped make the quadrant stronger and stronger until today we have a machine that is ideally suited for conditions of sugarcane thrash baling in Thailand. And of course, what is the number of such machines we have in Thailand? We have about 1,000 CLAAS quadrants already working. So these are pictures in the field, and what makes it possible for these hundreds of quadrants to work is of course the backup that we do provide from our dealerships in terms of aftermarket support, like trained people, spare parts availability, and so on. So this makes these quadrants work through the months from, let's say, December to March, April, May even sometimes, without too much of a challenge. Of course, there are downtimes because of the conditions, but we can provide backup through our staff and dealerships. So it's not just the quadrants. We also have other range of balers. We have the smaller square balers. So when it comes to paddy straw baling, Markant would be ideal, because paddy fields are a little different. They're smaller, and the conditions of the paddy fields are a little different from what you would see in a typical sugarcane field. So there you have the ideal machine, which is the quadrant, which is the Markant, lesser in weight and more ideally suited for smaller fields. And then we also have what is called a round baler or the Roland. We do have Rolands working here in Thailand as well. So that's the other option where you have round bales. The benefit of a round bale is that it doesn't compress as much. The amount of abrasive impact is lesser, and therefore lesser maintenance and wear and tear. But then they have the challenge, of course, that it cannot be as easily transported and stacked as a large square bale, because a large square bale is more dense. So you have pluses and minuses on each side. And then, of course, we do have the full range of tractors, material handling, and front loader arrangement, etc., to be a full solutions provider for the entire process. So the question is, we come back a little onto the economics without mentioning numbers. We'd be happy to discuss numbers, but of course, we would then be needing a little bit more time. So here I would give you the top bird's eye view of it. So the question is it profitable and is it viable? The very fact that we have 1,000 balers working is already the first indication that it is a profitable business to contractors. And the sugarcane thrash, which is used in the biomass power plants, is a constant demand from sugar mills. So there's absolutely no issue with demand, and the mills are actually running lesser than what they need, because by some estimates, when we talk to officials from the mills, the impression we get is that they only get 10% of their demand of cane trash. So there's no lack of demand, and there's no lack of supply. We have a limitless supply of sugarcane trash, really, 1.8 million hectares, and farmers are happy to sell if the farmers are paid for the trash collected. They would be happy to collect that money and not burn, and then of course it's a win-win situation. So there's a demand, there's a supply, and of course then you have the contractors connecting the two, and these are the people who invest in machines, who are willing to pay by some indications. But when we go out into the field and see what the amount is, we have the feedback that's where this process is working. Farmers are paid sometimes 50 to 100 baht per ton. It can be a little higher or lower depending on the location. And sugar mills itself, or power plants itself, pay between 800 and 1,000 bahts per ton. So, and it's working. It's viable and productive for both the sugar mill and the farmer and the contractor. So we have all the basic ingredients set up for a successful business model: great demand, limitless supply, and then people willing to connect, and equipment available to connect, basically. So, so where does the government come in, and what can they do? To be fair, the government is aware of this. They are already taking a lot of initiatives, and we already see steps in terms of government intervention and support. The very fact that senior officers from the ministry are participating and cooperating with the AQI initiative is already indication. But the thing is that a lot can be done, and a lot more can happen in order to accelerate the adoption. And this is where all of us can play a role, because it's really the most cost-effective way of addressing the issue, because you're really addressing the core of the problem. And the 6% of GDP loss can be addressed, and it's not just economic loss; it's also loss of life and a reduced lifespan, which we know is the result of all this. So the adoption rate already there is clear indication of a profitable business case. We do have a demand, but the challenge is for contractors to invest in equipment. There is an initial investment. Of course, the payback can be fast, can be 3 years, 4 years, and we already know from practical experiences from the contractors, the payback is about 3 to 4 years. Very realistic calculations. But the challenge is not all financiers understand the model. They have a hesitation in therefore financing, and this is something that should be eased out. And so there are some financing models available, but this can be amplified. So the government can come in addition to the ban and legalizing of punitive measures. What we need is incentives for a higher level of adoption. Some of it could be subsidized finance rates. Already we do see some examples where the financial rates are subsidized down to even 2%, sometimes even lesser. And so that is one possibility. The other could be direct subsidy on the equipment itself, or even, for example, subsidizing the cost of cane trash that is paid for by the power plant. So if it's 800 or 1,000 baht, the government can think of subsidizing a little bit of that. So there are multiple ways in which interventions can be made and accelerated, and therefore ensure a higher level of adoption. So it's really a win-win situation for all. We know that power plants need it. They have a local, cost-efficient, sustainable source of power production, because this happens year after year, and it's something that will continue as long as we have sugarcane production or paddy production, which is of course going to continue into the future. So the power plants would be happy. The farmer, of course, would have additional income, and he would not be punished for burning. Rather, he would be rewarded for not burning using the incentives. And of course, then you have contractors willing to connect the two, provided we give them a little bit of a helping hand on easier adoption. So it's really a win-win situation. And like Andreas mentioned at the very beginning, steps to reduce or mitigate pollution in the air does not necessarily mean a loss of, or a negative impact on the economy. So this is really what I wanted to stop with. And now I think we have more or less done with 42 minutes, and we are open now. We have time for the Q&A. I must have missed a lot of these.